Hello, this is Philippe Michelet, SVP Product Management at Kaloom. We have an exciting piece of news to share with you today, the availability of our unified edge fabric. Before we go for the demo, let's introduce the solution. So what is the landscape? With the support of high frequency bands, millimeter waves, 5G is technically capable of offering up to 1 gigabit per device. Networks will need to significantly change to accommodate this increase in bandwidth. But 5G is not just about bandwidth. It is a platform allowing operators to deploy new services leveraging lower latency like augmented virtual reality or video analytics like security monitoring, smart city analytics. One of the key features is what the industry calls slicing, which presents some interesting challenges, particularly from an automation and orchestration perspective. More about this a bit later today. This low latency is provided by access termination in a large number of smaller sites at the edge. And the vast number of sites essentially puts huge pressure on the operators to limit the size footprint, considering the severe power constraint with associated limitations in cooling. Beside the CapEx, a new management paradigm is required as well, considering the large number of sites. And last but not least, associated to the highest degree of security, starting with physical security. Now, let's look at the edge, because the edge has different definitions. So for this announcement, we are going to be focused as what you see highlighted in green called edge. Kaloom has already a shipping solution to address the partial edge and the central DC as presented here in the slide, using what we call SDF or software-defined fabric. To cover this announcement, as what you see here again as edge, we are combining all the experience we have accumulated with SDF with Red Hat OCP plus some additional secret sauce, and compacted everything in the smallest footprint possible today, which we will refer again as Unified Edge Fabric or UEF. Side note, what is identified here as the far edge on the left side is the next milestone, but for a different day down the road. Before we do a deep dive into Unified Edge in more details, let's talk a bit about containers. We are going to do a competitive analysis of containers versus VM, just articulate why we believe, and many others in the industry, that containers are just the way to go. By the way, it was not only obvious more than 5 years ago when Kaloom decided to use containers as the foundation of our SDF fabric. We can all agree today that it was the right choice because containers provide a significantly lower overhead, allowing servers to support several hundred of containers. Containers are just easier to use due to their lightweight approach with the ability to pull and run images in seconds. There are no conversations about portability between containers anymore. Everybody is using a standardized format, Open Container Initiative. And containers are definitely open, which is why they are now so prevalent across the industry, enterprise, telco service providers, and obviously cloud service providers. There are certainly some concerns about security, but let me address this point here directly. Particularly to Kaloom, we place our software images in a private registry in the OpenShift supervisor nodes. This provides support for operators in site without access to the internet, and as a bonus, it gives us extra security. One of the great complaints with container technologies when it first arrived was the fact that containers started with Docker were running with root privileges. All the containers running on our cluster have the least amount of privileges that they need to run. At the end of the day, our belief is that it doesn't matter. What you will see as part of the demo as well is the fact that we support the KubeVirt, which essentially allows a mix of VM and containers, offering the best of both worlds. Now, let's talk a bit about current Kubernetes platforms. Unfortunately, before you deploy existing Kubernetes platform, the network as the infrastructure must already be up and running. This is obviously a trend to run networking function as cloud-native applications. But the container platform itself requires the network to be deployed first, kind of a chicken and egg situation. Then there's the fact that if you want to go even further beyond L2 and L3, you need typically to use servers to run L3, L7 as firewall, DPI, etc., etc. And that means, again, even more networking functions. And then several Kubernetes platforms require an overlay network, which add even further cost beyond the traffic itself and the basic VNF. And then fundamentally, and not surprisingly, as designed by compute engineers, Kubernetes networking has several issues. Let's name some of those. It's really not a relatively scalable platform. It's already difficult to offload some of the networking function today. What we call multi-networking is not very well handled either. What about network policies and firewall? And at the end of the day, I would use the term brittle as ultimately overloading Kubernetes control system without any support for service chaining, which again, in the context of telcos, is absolutely fundamental. So how did we address that? Kaloom's networking for Kubernetes is designed with really a holistic view on Kubernetes and networking. It really provides an integrated and seamless support for multi-networks. It provides normal constructs such as services and network policies applied to all networks. It is by nature a multi-cluster, and as SDF provides, SDF is fundamentally a fabric which can be deployed across hundreds or potentially thousands of switches. It is really providing out-of-kernel networking and support for offload accelerators such as SmartNICs. It provides an infrastructure for service chaining. It does support L3, L4, up to L7 network policies with scalability and efficiency in mind. So again, before we run the demo, let's ultimately look at this environment as what you will see during the demo as either 3 switches with their control plane with the masters, or as part of the demo, 2 switches and a server running the third Kubernetes master. So at the bottom, you can see again the hardware with today P4-based Intel Tofino X Barefoot type switches with the ability to offload some of the tasks into Intel FPGA as Stratix 10, obviously leveraging DPDK as well. On top of that, again, all our environment relies on OpenShift as well as Core OS. And on the top of this layer comes our cloud native applications, everything which is required to basically run the fabric. For example, as you set the fabric, you need to be able to instantiate this fabric completely automatically. This is what the discovery service will provide. We provide obviously L2 and L3 services. But what you will see, even more importantly, is the concept of slicing. We call that vFabric, which allows, again, this fabric to be sliced into different contexts, fully isolated. And at the top, again, all the instrumentation based on netconf to basically program this infrastructure with northbound API for third-party tools to not only program, but to exploit the data. More to come as well during the demo with Prometheus. So enough talking. Let's talk for the demo, and let me introduce you to Niloy, our VP of Customer Experience.
Thank you so much, Philippe. So yeah, guys, I'm joined here today by one of our solution architects, Robert Santucci. And Robert has the Kaloom solution installed in one of our test labs. So Robert, why don't you go ahead and let's first start with the Kaloom UI. Let's show everybody what the demo environment physically looks like in our lab. So what you see here is the topology, the physical topology of a setup that you would typically find in a edge site. You have a pair of leaf switches with a peer link between them, and you have two servers. In this case, one functioning as a controller and one functioning as a worker. Now, this in and of itself isn't different. But Robert, if you go ahead and pull up the Red Hat OpenShift dashboard, one of the unique aspects is that this entire setup is also an OpenShift cluster. So here you can see that exact same setup that I showed you in the Kaloom UI. You're now looking at a Red Hat OpenShift container platform dashboard. And once again, we've got the leaves, we've got the server, which is serving as both a master and a worker, and we've got one server configured as a worker node. Before we go too far into the demo, let's take a look at what we've done to create this demo environment, right? So as Philippe was mentioning earlier, we needed to create a simulation of what we believe would be a typical environment that our customers would be deploying in. And for this demo, we've gone ahead and partnered with a Linux Foundation project called EdgeX. And what EdgeX has done is they've created a set of containerized functions that are needed by a lot of customers in edge application scenarios. Kaloom as an organization tries to partner very closely with the Linux Foundation in a lot of projects. We've partnered with Linux Foundation for networking on the Virtual Central Office initiative, and we've seen demos before through that initiative. So once again, on this slide, you're seeing the same topology you saw in the Kaloom UI and in the OpenShift dashboard. You've got two switches that are functioning as master workers, one server that is functioning as a master worker, and one server, sorry, that is functioning as a worker. Now, on top of this environment, we've created two slices. Okay, we're going to be creating two slices. One is a default slice, which is basically the initial slice that the system shows up with, and one that is an external slice. Now, this notion of slicing, as Philippe mentioned, is facilitated by the fact that we use a containerized solution. So each one of these slices will actually get their own set of pods, right? There's no sharing of any context, of any routes, of any information between slices. Each slice is isolated. And as you can see, within the external slice, we've created a public vRouter. And in the default slice, we've created a default vRouter. Now, one of the unique aspects of what Kaloom allows you to do, however, is export and import networks between the slices, right? So in many competitive solutions, you actually need an external router or a fusion router or mixing router. There's many different names to do this mixing of networks. Whereas in the Kaloom solution, we allow you to create multiple slices and actually share networks between them. So what you're going to see in this demo is you're going to see us create an external slice, attach two termination points, one representing a public interface and one representing a device network where the IoT devices would attach. The public interface actually terminates on a public vRouter, and we use a transit network to connect from the public vRouter to a reverse proxy that goes ahead and protects the internal network from being directly exposed to the public network. We've also got, in that same external slice, we've got the device interface, but the device interface we are directly importing into our default slice and attaching it to the default vRouter. Then on the other side, we've got a pod network, which you will see us deploy the EdgeX pods to. And then through this VM, we're actually able to use this VM to do the service routing function between the network that the devices sit on and the network that our pods sit on, right? So at no point in time are we having to take all, you can see there, right? It's a /23 that we've created for our pods. So you could have hundreds and thousands of pods running on the unified edge, but we're only selectively exposing certain of those pods through that service routing VM to the devices themselves, right? And once again, this is a very simplified version of the solution. Using this solution, you could run many containers, you could run many virtualized network functions, you could even deploy your workload as a combination of containers and VMs and run select VMs on certain networks, right? So you have full flexibility for what you're going to do in this environment. Another thing to be aware of is really the benefit of consolidating the management endpoints, right? So what we're able to do with our architecture is instead of having, say, a software-defined networking solution that has to have its own interfaces, having a virtualization environment that has its interfaces, a monitoring environment, and then various server and storage devices that have to be managed individually. One of the big things we do with Unified Edge is we consolidate all of those interfaces. So what are the interfaces we use? We use netconf for managing the networking functionality. And you'll see in today's demo that we can go ahead and with netconf, we can create networks, we can create routers, we can import and export networks, all of those functionality. We use OpenShift and the standard OC commands, your CI/CD tools, Jenkins, Git, etc., for managing not only our networking pods, but also the application pods. We use Prometheus for monitoring, both once again inside our environment and the application environment. And then across all of the switches and servers, we're able to use Redfish to provide lifecycle management and configuration. We won't be showing Redfish today, but you'll get to see the other management endpoints. So let's start by creating our external virtual fabric. So the first thing you see here is once again the Kaloom UI showing that we have the default virtual fabric, which is our basic virtual fabric. First thing we're going to do is we're going to create an external slice. Now, we're going to create this external slice through a series of netconf commands, which we are submitting via a CLI that we've created to issue netconf commands called yCLI. So go ahead and create the external slice, Robert. Right, so once again, we're formulating a netconf request, and the request is going to be create virtual fabric. Right, you can actually see the netconf request that gets submitted. And there you have it. Now on the UI, you can see a vFabric is being created and it's pending creation. So what's being done in the background is now all the pods are being created for the second vFabric. So now we have a tenant, but one of the first things we need to do is we need to take our external termination points and assign them to that tenant, right? So as a data center infrastructure provider, you are the one doling out which termination points go to which tenants. So Robert, if you want to go ahead and assign one of our TPs to the vFabric ID 2, show folks how easy it is to do that. Once again, the request that we're making is fairly easy to understand. Assign physical to virtual fabric, specify the virtual fabric, and then probably the most complicated part of the command is describing the termination point itself. All right, so it assigned it successfully. You can see in the UI that there's one termination point, and then if you go click on tenant 1, you can see that the termination point we just talked about is now attached to the slice. So now we can go in and we can log into our tenant itself. Let's go ahead and do that, Robert. We can then create our L2 segment for our devices. We're just going to call it in-band IF01 for right now. Okay, so that creates the network. Once again, you can see the netconf command. So then we're going to take that network, we're going to attach it to the termination point we just created, right? So we had the data center infrastructure provider assign us a termination point. Now we're going to go ahead and we're going to attach that network we just created to that termination point. Like I mentioned before, we can actually take that network that's attached to a termination point and export it to our default vRouter that is sitting in our default vFabric. Now we have that network available in our default vFabric for us to attach a VM to it. We can log into the default vFabric. And here we can now go to our vRouter, FCN0, which is our default one. And we can, within there, we can see that we've taken that network that we imported, we've attached it to the default vRouter, we've assigned it a subnet. Now what we're going to do is we're going to go ahead and put a VM on that subnet. So now that we have the networking set up, we're going to go ahead and create our virtual machine. Now this is just a standard OpenShift OC command. So go ahead, Robert. Further, you can now console into that VM, and we can see that the VM has two interfaces, one that is sitting on that network that we imported from the external slice, and the other that is sitting on the transit network to the pods. So we can see that the VM has been created within our OpenShift environment. And most importantly, we can see that that VM is actually running on a leaf, which is important for traffic flow efficiency. All right, Robert, let's go ahead and switch to the pod view, and let's go ahead and deploy the EdgeX application. Here you can see Robert's using a standard Helm-based approach for executing the deployment. And as those pods come up, you can see those come up in the OC dashboard. So we've deployed this VM, and for the purposes of the demo, we're just running HA proxy on the VM, right? Now, obviously, as a customer, you could run a much more complicated load balancer implementation with filtering and things like that. But what we've done in this case is we've taken the IP address of the service that we're presenting, in this case, the EdgeX UI. And as you can see here, we've mapped that to the external IP address using HA proxy. So there you have it, folks. We created the VM, which is functioning as a service router in this example. It's sitting on that external or device-facing 1030.0 network. And here we have an endpoint, which is 1030.0.4, which is essentially presenting the EdgeX UI, right? So here we have the EdgeX UI and sort of the UI dashboard pulled up. So you would, if you had a device on your network, you would be accessing the services that EdgeX provides. As you can see, the services are up and running. You'd be accessing the services that EdgeX provides through that VM, right? That VM is the one holding that IP address. So as we talked about earlier, we're not only using OpenShift for the provisioning aspects, but we're actually also able to use Prometheus for its dashboards. So when it comes to using Prometheus for its dashboards, because we're using OpenShift as the networking function, there's actually multiple roles. So if you're the data center infrastructure provider or manager, you care about what resources are available to all of my customers. So this is the example of a Prometheus dashboard that you might use. As you can see, we're looking at all of the compute resources in the cluster. You're able to see the CPU utilization, memory utilization, etc. So this gives you the visibility to, from a DCIP or data center infrastructure provider, what am I providing to my users? Now, Robert, if you go to the other tab, we've also pulled up a view of what an application owner would care about, right? So in this case, as you saw, we deployed EdgeX into its own namespace. And now I'm looking at the CPU utilization from an application owner standpoint, right? What is the workload that's running on there? And I could pull up any of my pods in this space. I can go ahead and see what type of load I'm seeing, etc. So through a single component, right? Once again, the message here is all about consolidation. Through a single component and using rights and namespaces and things like that, I'm able to see both an infrastructure provider view as well as an application owner view. So what would we show in this demo today? Well, first of all, we showed a single point of management for both the cluster, the OpenShift side of the house, and networking, right? So whether it was a virtual network, a physical termination point, or creating a VM, we were able to do those through a unified set of management points. We actually showed deploying containerized network functions and virtualized network functions. Most importantly, we were able to deploy them on the switch, which allowed for optimal traffic routing. And lastly, we were able to show that we were using standard OpenShift tools and commands so that any customer, any party who has a pipeline that they have integrated with OpenShift, they can leverage this platform and they can deploy their application across thousands of edge sites. So where can we expand this? Well, first of all, what we didn't show today was the UPF portion, right? So one of the advantages of the Kaloom solution is that we can actually deploy the UPF as a part of our solution. It can also run on our leaf switches. So if you have external connectivity from 5G devices, that can run on the same piece of hardware. We also didn't show the ability to have the connectivity between our service routing VM and the Nginx pod, which is functioning as a reverse proxy. If you build that connectivity, you can actually have some services running in public cloud while all of the devices are still protected by that service routing VM. So Philippe, let's talk about some of the value of having all of these components in a single unified solution.
Thank you, Neil. In conclusion, as you saw during the demo, without UPF, Kaloom's unified edge fabric significantly reduces both CapEx and OpEx by making more servers available at the edge. OCP masters can run in the control plane of the switches as part of the Kaloom's operating system with the same control and management plane for the entire rack. With UPF, the value increases even further as demonstrated here, bring even more servers from the rack. Again, what is typically implemented as software running into servers is now basically executed in the hardware, in the Intel Tofino ASIC as accelerated, providing more than a terabit per second of accelerated UPF traffic. This ultimately provides a significantly lower cost of ownership, which ultimately will accelerate the return of investment with the vast majority of the resources in the rack on the right side available for monetization for whatever the infrastructure is, obviously telco service providers, but the enterprise in the context of a private 5G deployment.